Hello CSIR NET aspirants, welcome to Old Paper Solutions, your guide for competitive exams in physical sciences. Here we are solving question from part C of CSIR NET exam conducted in June 2022. The question reads as the value of integral cos alpha x upon x square plus 1 dx from limits minus infinity to plus infinity for value of alpha greater than 0 is, and options are option 1 pi into e to the power alpha, option 2 pi into e to the power minus alpha, option 3 pi into e to the power minus alpha by 2, and option 4 pi into e to the power alpha by 2. Let's start the solution. Let us consider integral f of z dz over c, which is tracing semicircular contour in the complex plane and real axis from minus r to r as shown in the figure. Here f of z is equals to e to the power I alpha into z upon z square plus 1. Poles of f of z can be written as z square plus 1 is equals to 0. Therefore, z square is equals to minus 1. So the roots of z are equals to plus minus I. The only pole enclosed by contour C is at z is equals to I. As we can see here in this diagram, the pole at z is equals to I, which is the only pole enclosed by contour C. So the residue of f of z at z is equals to I is calculated as limit as z tends to I, z minus I into e to the power I alpha z upon z square plus 1. It is equals to limit as z tends to I, z minus I into e to the power I alpha z upon, we can simply write z square plus 1 as z plus I into z minus I. So here we get limit as z tends to I, e to the power I alpha z upon z plus I. Since the similar terms z minus I and z minus I are cancelled out. So this is calculated as e to the power I square alpha upon I plus I, which gives us value of e to the power minus alpha upon 2i. which is the required residue of f of z at z equals to I. Now, by Cauchy's residue theorem, we know that integral f of z dz over contour C is equals to 2 pi I times sum of residues. This we can write by substituting the value of f of z as e to the power I alpha z upon z square plus 1 dz is equals to 2 pi I times residue calculated at z is equals to I. This we can further write as integral from minus r to r e to the power I alpha z upon z square plus 1 dz is equals to 2 pi I times calculated residue at z is equals to I is e to the power minus alpha upon 2I. This is equals to pi into e to the power minus alpha, since 2 and I, these terms are get cancelled. Now we will take real and imaginary parts separate and will write as integral from minus infinity to plus infinity cos alpha x upon x square plus 1 dx is equal to pi into e to the power minus alpha, this is the real part, and integral from minus infinity to plus infinity sin alpha x upon x square plus 1 dx is equals to 0, which is the imaginary part, since sin alpha x upon x square plus 1 is an odd function, it becomes 0. So we have got our final answer for integral from minus infinity to plus infinity cos alpha x upon x square plus 1 dx is equal to pi into e to the power minus alpha. So that option number 2, which also reads as pi into e to the power minus alpha, is the correct answer to our question. Hope you found this solution helpful. Do like, share and subscribe our channel for more such solutions. Thank you.